This is Calculus Lesson Section 4.1. And the name of it is the extreme values of the function. So I want you to look at this function. It's a parabola. It has ends that go forever, but it also has a point down here, a vertex right here, and we would call this the absolute minimum. There is no y value below that point. Now, I can change my curve so I can create something called an absolute maximum. So if I would take and I would have an endpoint here and I would erase this piece, and basically I look at just this much of the curve, this point still becomes the absolute minimum because it has the lowest y value. This point right here would be called the absolute maximum because there is no y value that's greater than that one. And then we have this little guy over here. And it sometimes is called a local maximum. It looks like it's a high point, but there's another one that's higher than that. Sometimes, and I use this from other books, they will call it a relative maximum. So for terminology, you see it both ways. All right, so copy the picture and the pieces, and again, you can stop this video at any time and then start back up. All right, the first thing, this first chapter is more, this first section is more about terminology. The first thing they're going to talk about is extremas. Those are points where we have either the minimum or the maximum occur. Then we talked about absolute minimums and maximums. In other words, this has to be the lowest y value, whereby this one is the top y value. And then we have something called the extreme value theorem. First of all, it only is working on an interval. An interval that includes the endpoints. The function is continuous, and somewhere between the y values of each of these two endpoints, I'll have my f of x. And if you notice, I wrote down the absolute maximum and the absolute minimum. Again, this is still just terminology. Now, we're going to be asking you to use the first derivative to find the extremas. The first derivative is found, the c values, those are my local extremas, where the derivative equals 0. So if you have a function, you take the derivative, set it equal to 0, and solve. The candidates you get for x will be called extremas. In other words, something happens at those points. I really don't know what's going to happen and don't really care at the moment. But something major happens. Then they talk about a critical point. Now the difference is with the critical point than the extremas, we are also allowed where we have an undefined. So in other words, where our function is not defined. And we're talking about the derivative here. So if we have a place in the domain, everyone remembers the domain are the x values. If there's some place that we have an undefined for that derivative, we will also use that as a critical point. All right. Basically, there's more information, but I want to go look, and I'm going to look at 45. This is 45 on page 229. I want to know what the critical points are. The critical points are where the derivative equals 0 or it's undefined. So this one is very simple. I find the derivative. I set it equal to 0. So I know I'm going to have a critical point at 3. I don't know exactly what's happening in 3, but that's what I'm gonna deal with.
Anyone who can get on the elementary school master, would you please call 4001? Anybody who can get on elementary school master, 4001, please.
Ignore that message. Then I want to look at 51 with the same instructions. So the first thing I'm going to do is rewrite it. So I have x to the 1/2. Then I'm going to take the derivative of this. So I take 1/2 times there, so I get 16x to the negative 1/2. Now, what I need to do with this, I have to let it equal to 0, and I need to rewrite it. So I'm going to have 2x minus 16 over the square root of x equals 0. Now, can everyone see that at x equals 0, I would have an undefined? So one of my critical points is eventually going to be x equals 0, because that's where it's undefined. But to solve this one, I'm going to add the opposite to the other side, cross multiply. I'm going to rewrite this to x to the 3/2 power, because they're both square root. This is like 1/2 to 1, so I added. And now to solve this, it's a very simple process, taking both sides to the 2/3. And if I take 8 and take the cube root of it, that's 2 squared is 4. So my two critical points will be at 0 and 4. All right, this is basically a beginning lesson. One of the things that you are going to be asked to do, you're going to be asked to locate minimums and maximums. And basically, you're going to start with just looking at the graph, and then you're going to tell me where the minimums and maximums are located. Absolute ones mean that they're the lowest or the highest possible. Local ones mean they're kind of in the middle. So that's one of the things you're going to do on homework. Then they're going to talk about extremas. If they have the extreme value, they basically just want to make sure, is it continuous and your function is between the two y values. Then we're going to use our first derivative. We're going to take the first derivative, set it equal to 0. If it equals only 0, that's where we'll find extremas. But if we want all over critical points, which are more, you're going to have the derivative equal to 0 and the derivative where it's undefined. And then, when you get ready, oops, one more, you just take the derivative, set it equal, and solve. Good luck. Remember, this assignment won't be due till next Thursday.